Hi everyone, welcome back to our channel. Today we are going to solve this problem. The given question is write the loop equation for this transformer coupled circuit. So here you can see here, this is the primary of the transformer, this is the secondary of the transformer. You need to write down the loop equations. So this is called loop or this is called mesh, both are same. Okay. So now let's try to write down. So I am assuming the current in this branch is flowing in the direction what have been marked, and here also I am assuming the current is flowing in this direction. Okay, so these are the two currents flowing as per my direction mark. Now let's try to write down. So now try to apply KVL. So in order to write down loop equation, we need to apply Kirchhoff's voltage law at loop 1 or mesh 1. So loop is also called as mesh 1. Okay, so this is mesh 1. So we are exciting with an AC supply. So generally, in order to understand the polarities, I am marking as plus. So KVL is equal to voltage source. Voltage source is how much? V1 is equal to. Okay. So current I1 is traveling across this resistor. So therefore the drop is I1 into R1 is the first term. And the drop which flows here is so what is the resistance formula? Plus J5. So we can write it as I into R. Okay. So the self inductance is how much? Plus J5 ohms. So this is like plus J X L ohms. Okay. What is this? XL is inductive reactance. This can also be written as J omega L ohms. So this is the style of writing. So what is the self inductance now? So plus drop I into R. Okay. So what is the I value? I1. Okay. So what is the R value? Which is nothing but plus J5 ohms is the drop. Okay. Next one. Coming to here. Now self-inductance is completed. But this coil is linked with another coil with the mutual inductance of how much? Plus J XM. So the mutual inductance is given by the formula plus J XM. XM is the mutual inductance. So this can also be expanded as plus J omega M ohms. Okay. So this is the mutual inductance value when it is given as omega M is how much? So plus J XM value given is how much? 7. Okay. So this is the value given. You can see here how to mark the polarities. So I1 current is entering the dot. So this current is entering the dot, but this current is also entering the dot. Whenever both the currents are entering the dot, dot indicates starting of the winding. So both the currents are entering the dot, therefore you are going to get positive polarity, and mutual inductance is how much? Plus J7 ohms. Okay, this is a form of I into R. What is the I value you are going to get here? Which is nothing but mutual inductance due to another coil. Therefore, you have to write down it as I2. So I into R. Okay, so that's how we have been obtained first equation. So coming to the second equation, here also you try to apply KVL equation. Okay, so apply KVL at loop 2. So loop 2 is also called as mesh 2. Loop or mesh both are same. And directly I can say that this is one isolated circuit, this is one isolated circuit. So this is called electrical circuit 1, this is called electrical circuit 2. More than 2 electrical circuits are there, therefore this I can call it as an electrical network. Okay, now let's try to apply the KVL for the loop 2. Okay, so here there is no voltage source. Okay, I can call this as voltage source is equal to voltage drop. So what is the voltage source here? No voltage source is there, but the drop is there. How to write down this drop? So I can write down the drop as so the drop is start from this resistor. The drop is I2 into R2, which is nothing but I into R. Okay, what is the drop created by this inductor? Self inductance is so it is J6 ohms into I into R. What is the I value which is flowing in this branch? Is nothing but I2. So I into R is nothing but the amount of voltage. Now this coil is linked with the primary coil with the mutual inductance of how much? Plus J7. Let's try to write down. Here also you can see here the current is entering the coil, and here also the current is entering the coil. Therefore you are going to get positive polarity. So voltage can be written as V is equal to I into R. What is the amount of current? Okay, so the current of mutual inductance is due to the first coil, which is nothing but I1, and what is the amount of inductance, which is nothing but plus J7, okay, ohms. Okay, so So generally we'll write down r into y, which is nothing but ir into r. It's very simplified. Okay. So now let's try to take common. So here what is the common term we are going to get? It is v1 is equal to I1 of r1 plus j5, which is nothing but plus jxl. Okay. And j7 into I2 will act as an equation number 1. Okay. So 0 is equal to, so let's try to write down I1 term as first, which is nothing but I1 j7 ohms. So here take I2 as an common term. When you take I2 as a common term, then you are going to get R2 plus j6. So let's try to take this as an equation number 2. Go to your and you solve it. So but actually we can't solve, why? Because R1 is not given, R2 is not given. Generally if R1 is given, we can solve and we can find out the current I1 and I2. Then you can find out the drop across J5, or you can find the drop across J6, or you can find out the drop across R2. Okay, that's how to find out. So now generally the problems will be given is find the voltage across the drop across the which resistor? R2. What is the drop across R2? Which is nothing but, the drop is nothing but I2 into R2. Okay, so R2 is not given. So if R1 and R2 is given, we can solve and we can find out this drop. This is how to write down the loop equation. Very simple. So whenever the current is entering the dot and current is also entering the dot, that's why I got positive. In the second also, current is entering the dot, current is entering the dot, that's why I got positive. Coming to the currents, so for this coil you are writing, therefore the mutual inductance is due to which coil? Another coil. That's why I written I2 with respect to loop 1. But when you come to the second coil, so the mutual inductance is due to J7, but due to current in which coil? Primary coil. That's why I written plus 1. Okay. So mutual is due to another person. That's why here we are writing for self and we are considering the another current is I2. Here we are writing for second loop and we are considering the current of the primary. This is how to write down the loop equation. If you feel my content is good, please like the video and share with your friends, those who are studying this subject. If you have any doubts, let me know in the comment section. And if you're watching my channel for the first time, kindly subscribe to my channel for more updates on my channel for more unsolved problems. Kindly encourage this sort of free channels for the development of students and faculty. Thank you for watching. We'll meet with another beautiful video. Yours from